Good evening, everybody. Professor Ayorinde welcoming you to another online session in organic chemistry. In today's session, we are going to review for exam number 4. And since most of you are in Dr. BAKARE's class, we are going to use a previous exam number 4 from Dr. BAKARE. For that, we are going to go over questions 6, 7, 4, 2, and 3. And if time permits, we might do additional problems. I know many of you have already joined us. During the course of this session today, I will be acknowledging each one of you. Okay, so let us go to problem number 6. Ayana, can you do us a favor and read question number 6 for us?
Give the main organic compounds formed in each of the following reactions.
Okay, thank you so much. Okay, so this question says, give the main organic compounds formed in each of the following reactions. Now, this is one of those reactions set of problem that you need to know what your reagents will do. In this particular instance, we are going to be dealing with the Grignard reagents. Okay, so but before we go into this particular set of problems, I would like to give you a little bit of background with regard to the Grignard reagents, particularly with respect to the mechanism of Grignard reactions with carbonyl compounds. For example, if you have a Grignard reagent, let us use this as an example. Let us use a generic example. Say we have this. Okay, this is a Grignard reagent in which you have magnesium is bonded to a carbon atom, and that magnesium is also bonded to a bromine atom. With regard to the Grignard reagent and the reaction mechanism, I would like for you to think of the Grignard reagent as this type of molecule here. In which case, the bond between magnesium and bromine is an ionic bond. So the bond between magnesium, I'm sorry, I take that back. The bond between magnesium and carbon is an ionic bond. In other words, this is here, even though we are showing that this bond is covalent, it is not a covalent bond. So think of it as ionic bond, just as you think of sodium ion and chloride ion. And as such, this part of the molecule right here, we will refer to that as a nucleophile. So we say that this carbon here, the carbon that is negatively charged, is nucleophilic. In other words, it has the ability to bond to other carbon atoms. For example, supposing we have this Grignard reagent here. If we have this, this part of the molecule, this is your nucleophilic part of the Grignard reagent, and this carbon here is your nucleophilic carbon right here. Similarly, if we have this, this is your nucleophilic part of the Grignard reagent, and this carbon here is your nucleophilic carbon. Now, having said that, let us take a look at the carbonyl molecule. Because for the Grignard reaction, for the most part, the Grignard reagent will be reacting with carbonyl compound. Okay, let us take a look at this carbonyl compound here. Okay, this molecule here, this is a ketone. Now we could write a resonance structure for this ketone, in which the pi electron between the carbon atom and oxygen goes to the oxygen. And therefore, we could write another resonance structure for this ketone. In which the carbonyl carbon is now positively charged, and the carbonyl oxygen is negatively charged. So these two are resonance structures of each other. So let us call it molecule A and molecule B. These are resonance structures of each other. And as a result of the resonance contribution, we will say that the carbonyl carbon is electrophilic. We say this carbonyl carbon here is electrophilic. In other words, it wants to react with a nucleophile. So now what do we have here? We have the Grignard reagent is nucleophilic. The carbonyl compounds, the carbon of the carbonyl compounds are electrophilic. So the two now will react to come together to form a new molecule. Let us see what happens here. Supposing I have this Grignard reagent, and I have this carbonyl compound, what do you think will happen? Can anybody tell me what do you think will happen? I have the Grignard reagent, which will act as a nucleophile, and the carbonyl compound will to act as an electrophile. What do you think will happen? Anybody has an idea? Okay, okay, very good. Somebody, Ayana, go ahead and ask your question.
I was just going to answer your question, that's all.
Yeah, go ahead and answer the question.
The negatively charged carbon is going to want to go with a positively charged carbonyl in the carbonyl group.
Excellent, excellent. Okay, so what is going to happen here? This nucleophilic carbon here, keep in mind you have to show, if you have to show reaction mechanism, you have to show your arrow, will attack this electrophilic carbon, and the pi electron, of course, will go to the oxygen. And so what do we have here? We have this. And then the Grignard component will now be here. Okay, so now we have the Grignard component right here. And of course, the magnesium bromide will simply just be tagging along, be there somewhere here in solution. So at this point, if we now add dilute acid in the form of hydronium ion, what happens? We have dilute acid in the form of hydronium ion. We get just use green here to show the hydronium ion. So we have the hydronium ion. So what is going to happen? The negatively charged oxygen here will now act as a base to abstract a proton from the hydronium ion, thereby releasing a molecule of water. And so what we have here, we end up with this product. So what we have here, we started with a ketone, we reacted the ketone with a Grignard reagent, and we ended up with a tertiary alcohol. A tertiary alcohol. Okay, so let us recap everything that we've done so far. Okay, so what we have here, we started with this Grignard reagent. Reacting with a ketone to form an intermediate alkoxide ion. And then when we protonated the intermediate alkoxide ion, we ended up with a tertiary alcohol. So therefore, if I ask you, anytime a Grignard reagent reacts with a ketone, what class of compound do you get? What would be your answer? Anytime a Grignard reagent reacts with a ketone, what class of compound do you get? Tertiary alcohol. Excellent. So keep that in mind. That is very important. Now, supposing you now have the same Grignard reagent Supposing we have the same Grignard reagent, react with, say, step 1. Step 1. By the way, what class of compound is this here? The one I've just given you here to react with the Grignard reagent. An aldehyde. Excellent. Okay, so we have step 1, the Grignard reagent reacting with an aldehyde. And then step 2, we add hydronium ion. What class of compound do you think we are going to get based on what we did with the ketone? Secondary alcohol. Excellent. Secondary alcohol. That is correct. You are going to get a secondary alcohol because the Grignard carbon here will attach itself to this carbonyl carbon, and the carbonyl oxygen becomes your alkoxide, and then eventually you are going to add hydrogen to that after the protonation. Okay, so let us see what will be the product for this. Get this out. Okay, so the product therefore will be okay, this hydrogen was there before. Okay, let me use a green arrow to show the hydrogen coming from the hydronium ion. And of course, the alkyl group coming from the Grignard, that is this here. Okay, and this you guys already told me this is a secondary alcohol. Okay, so now let me give you a table of what you expect to get when Grignard reacts with different classes of compounds. Okay, so let me say Grignard, let's just say Grignard plus ketone equals to tertiary alcohol. Grignard plus aldehyde equals to secondary alcohol. Keep this in mind. Grignard plus the simplest aldehyde, which we call formaldehyde, which is this here. It's called formaldehyde. That is the simplest aldehyde. What you get a primary alcohol. In this case, you only are going to add one carbon atom to the Grignard reagent. A Grignard plus an epoxide, ethylene oxide. A Grignard plus ethylene oxide, which is this here. We call this ethylene oxide, okay, equals to a primary alcohol. In this case, you are going to extend the carbon chain by 2 carbon atoms. Okay, let us continue. A Grignard plus an ester, you get a tertiary alcohol, just as in the case of secondary, a ketone reacting with a Grignard reagent, you get a tertiary alcohol. A Grignard plus any acid. Okay, in this case, carboxylic acid. Okay, what do you get? You get either an alkane or an alkene, depending on what your Grignard reagent is, or a benzene type molecule, depending on the Grignard that you are starting with. Okay, so let me recap all of this for you so that you guys have an idea what this table looks like. Okay, so what do we have here? Grignard with a ketone, tertiary alcohol. Grignard with an aldehyde, secondary alcohol. Grignard with formaldehyde, which is the simplest aldehyde, primary alcohol. Grignard with ethylene oxide, which is an epoxide. You have a primary alcohol in which you have extended the carbon chain by 2. You have Grignard with an ester. You have a tertiary alcohol. And then Grignard with carboxylic acid. You get either alkane, alkene, benzene, depending on what Grignard you started with. Yeah, I almost forgot. There is one more Grignard reaction. Let me give that to you. Grignard with carbon dioxide. Let's see here. Grignard with carbon dioxide. Let us see here. Grignard plus carbon dioxide, which is this here. Okay, that gives you a carboxylic acid. After you keep in mind all of these reactions, once you do your Grignard reaction first, then you follow it up with hydronium ion or dilute acid. Okay, is there any question before we go to question number 6? So we could finally answer question number 6. Now, if you understand what I've just given you, give me a happy face. Okay, 7. Very good. Okay, let us now go. Let us go back to the question. That is 6. Okay. Now we are now going to go ahead, given that we now should understand some of the reactions of the Grignard reagent. Let us simply. Okay. Let me ask you this. I need your assistance here. Question number A. This Grignard here is reacting with what class of compound? Anybody? What class of compound is the Grignard reacting with, which is this here? What class of an aldehyde? Excellent. So therefore, what class of compound do you expect the product to be? Keep in mind this is a secondary alcohol. Excellent. Secondary alcohol. Okay, so let us now draw the secondary alcohol. Okay, so the secondary alcohol will be this here. Let me go ahead and write this. This is okay. And the component, the alkyl group from the Grignard reagent, let us use a black pen to show that. So we have this here. That's 1, 2, 3, 1, 2, 3. Okay, so this is the product of question number A. Let me make this smaller for you guys. Okay, so this is the product for question number A. Okay, and what have we done here? You have a Grignard reagent, this Grignard reagent here, reacting with an aldehyde, this aldehyde here, and then you follow that reaction with hydronium ion, and you end up with what we have here is secondary alcohol. You notice here, this part of the molecule here, this part of the molecule came from the Grignard reagent. Okay, about B. Question B, this here. A Grignard reagent reacting with carboxylic acid. What class of compound do you expect to get? A Grignard reagent reacting with carboxylic acid. Let me go ahead and erase this. Get this out of the way. A Grignard reagent, where exactly? A Grignard reagent reacting with carbon dioxide. I'm sorry, I said carboxylic acid. I gave that away. Yeah, the answer is carboxylic acid. Okay. Okay, so you have your Grignard reagent here. The Grignard reagent here. Of course, you have carbon dioxide. So how many carbons do we have in the Grignard reagent? 1, 2, 3, 4, and 5. So let us draw that. Okay, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. And then we have the carbon from the carbon dioxide. Okay, so the answer to B is this here. Wait a minute. Okay. Sorry about that, folks. Okay. Okay, just give me, I think I'm having a little bit of technical problem here, so let me go back to this here. Okay. I will be right with you. Okay. Oh, just 1 minute. Okay. 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 Now the answer to this here is this. That is the answer to B. Okay, no problem. Somebody said they have to go. About C. For C, a Grignard reagent reacting with what class of compound is it going to react with? Okay, a ketone. And what is the product you expect to get? Tertiary alcohol. Excellent. Somebody said tertiary alcohol. That is correct. You get in this here. Okay. Tertiary alcohol. So let me get this out of the way. Something is going on with my system here. Get this out of the way. Okay, so we are going to get this Grignard reacting with this ketone here, so therefore the product will be this here. And let's use a different color pen to show the component from the Grignard. How many carbon is there? 1, 2, 3, 4. 1, 2, 3, 4. Okay, so therefore this is the product from the Grignard reacting with a ketone. In this case, what class of compound is this? Okay, I see here, tertiary alcohol. This is a tertiary alcohol. Okay. Okay. Now let us go to the next one. D. D. A Grignard reacting with ethylene oxide. What product do you expect to get here? Primary alcohol. Excellent, excellent. Primary alcohol. Okay, so let us get this out of the way. Okay, this is question D. Okay, so we say how many carbons do we have? We have 1, 2, 3, 4, 5. So we have 5 carbon in the Grignard reagent. So that is 1, 2, 3, 4. 1, 2, 3, 4, 5. And then we have the carbon from the ethylene oxide. Let us use the black pen to show that. That is this here. This here. And that is your primary alcohol. You notice what have we done here? We have extended the carbon chain by 2 carbon atoms right here. Okay, very good. Okay, now let us do E. Now E is a different set of problem. Let's erase this. Okay, we do E. Okay, in the case of E, this is not a Grignard reagent. This is what we call the Gilman reagent. Take this out of here. This here is your Gilman reagent. We call this Gilman. That is your Gilman reagent. Now, in the Gilman reagent, for example, if you have a methyl copper lithium reagent, which is an example of a Gilman reagent, what I wanted to do here okay, let's see what's going on here. Okay, what I wanted to do here, think of the Gilman reagent as a source of nucleophilic carbon. In other words, that pen is acting up on me. Okay. Folks, just bear with me a minute. I think I'm having a little problem with my pen here. Wow. Tamara, is your mic working? If it's not, okay. Eba Ayana, go ahead and read question number 7 for us.
Write the structural formula for the principal organic product formed in each of the following substitution reactions.
Okay, thank you. Okay, in this particular problem here, this is one of those problems in which all you need to do is to know what your reagent would be doing. In this case, we are starting with this alcohol here. What class of alcohol is that? What type of alcohol is that? Okay, primary alcohol. Okay. Now, what happens when you react a primary alcohol with phosphorus tribromide, which is this here? A bromide. What kind of bromide do you form? Primary bromide, exactly. In that case, we are going to replace the hydroxide of the primary alcohol with a bromine atom. So how many carbon do we have here? 1, 2, 3, 4, 5. So you see now doing what I wanted to do. 1, 2, 3, 4, 5. Okay. Okay. So we end up, let me do this better than that. So we end up with this product here, an alkyl bromide, which is this here. Okay. Okay, now what happens when you react a primary alcohol with thionyl chloride, this here? What happens when you react a primary aqua with, a primary chloride? Excellent. Excellent. Okay, so let us get this out of the way. So we are going to form a primary chloride. Okay, let us use a blue pen, and that will be this here. Okay, 1, 2, 3, 4, 5. And so this is the product for that. Okay, now at this point, we are now going to react compound A, which is this here, with sodium methyl sulfide. The sulfur here will be acting as a nucleophile. I will tell you now, this will be an SN2 reaction. So what product do you expect to get? What do you expect to happen here when compound A reacts with sodium methyl sulfide, SN2 reaction? Okay, and therefore you are going to replace the chlorine atom. Very good. Okay, so we have this. So therefore the product is this. The sulfur is here now. This here. And that is the product for, that is B. That is B right here. Okay. Now, we are also now supposed to take compound C, which is this here, which is the bromide. Compound C, which is this here, we're supposed to take that and react with sodium cyanide. The cyanide here, or the nitride, will be acting as a nucleophile in an SN2 reaction. So what kind of product do you expect here? What do you expect? Okay, SN2 reaction. Okay, very good. And what will happen? This is for compound E. What do you expect to get? We are going to replace the bromine with the nitride. Very good. Okay, so we get this. It's a black pen. So therefore, that is compound E. That is E right here. And finally, we are supposed to take compound C and react with sodium acetate, which is this here. The sodium acetate here will be acting as a nucleophile and reacting with compound C, which is a primary alkyl bromide. So what kind of reaction do you think we are supposed to get here? Okay, what do you expect to get? This sodium acetate, which is this here, reacting with, okay, very good. Very good, we are going to get an ester. In this case, we are going to displace the bromine with the acetate. So therefore, the product will be this. Very good. Okay, that will be this here. And the ester part will be here. Okay, and that is this here. That's what we have here. So in each one of these cases here in problem number 7, this is simply a question of knowing what your reagents will do. Okay, now finally, let us go to question number 4. Question number 4. Let me see here. I think Yana is the only. June, is your mic working? If your mic is working, can you go ahead and read question number 4 for us?
outline the reaction scheme to show how you would carry out the following transformation going via a Grignard reagent.
Okay, excellent, very good. Now, you notice why I decided to do question number 4 after question number 6 and 7. Because in question number 4, now you have to use your knowledge, the knowledge of question 6 and question 7, in order for you to do question number 4. This is where you now have to begin to use your own critical thinking skills. Now, what do we have here? We want to go from this alcohol here to this secondary alkyl halide. We're going from a primary alcohol to a secondary alkyl halide. Okay? I am going to also, at this point, make an assumption that this carbon here, let us call this carbon number 1, and we call this carbon number 2. Let us say those will be this carbon here, 1 and 2, okay? And also, we also see here, if we go ahead and number the rest of the molecule, if we call this carbon 3, just for the sake of this discussion, say this is 3, this is 4, this is 5, this is 6, and this is 7. Now we notice here, we have to make a new carbon-carbon bond between carbon 1 and 3. Okay? If we assume that we are starting with this primary alcohol here. Okay, so this is a case in which you have to do what we call retrosynthesis. Retrosynthesis. In other words, we are going to go backward from the product to the starting material. Okay, taking one step at a time, keeping in mind everything that we know about question number 6 and question number 7 that we did earlier. Okay, let us see what we can do here. Take this out of here. Okay, so what we want to do here, we want to take one step at a time. Okay, can anybody tell me what is that one single reaction that will give me this product, the product that we need to make? What is that one single reaction? Excellent. Okay, Chelsea say use thionyl chloride. Okay, use thionyl chloride with what? That is a good one. Use thionyl chloride with what? Okay, well, that is, pyridine is the solvent, that is fine. But what will be the substrate? What will be the substrate? What are you going to react thionyl chloride with? To form this second, keep in mind you have to form a secondary alkyl halide. Okay? What are you going to react the thionyl chloride with? Okay, secondary alcohol. Excellent. Very good. You are going to react with a secondary alcohol. Okay, so we say, okay, if that is the case, this must be that one single step Okay, so that means we have this secondary alcohol reacting with thionyl chloride. Now, if you agree with that, give me a happy face. Okay, very good. So now we form this secondary alkyl halide. Now the next question is, what is that reaction that will give you a secondary alcohol? What is that single reaction that will give you a secondary alcohol? What reagent do you need? Aldehyde and what? To give you a secondary aldehyde and what else? Keep in mind what we did in question number 6. To get a secondary alcohol, what do you need? Aldehyde and to form a secondary alcohol, what do you need? Aldehyde and what? And Grignard, excellent. Aldehyde and Grignard. Okay, very good. If you are going to form use aldehyde and Grignard, then you could make an assumption that this part of the molecule could be your Grignard. Okay? Keep in mind our starting material is this one here. Keep in mind this is our starting material. So if we say this part of the molecule is the Grignard, therefore this part of the molecule must be your aldehyde. Okay? So if that is the case, how many carbon do you expect in the aldehyde? Can anybody tell me? How many carbon atoms do you expect in the aldehyde? 5. Excellent. Okay, so therefore, we will say therefore our Grignard will be this. Okay, the reaction will be this. We'll take a Grignard. We'll take an appropriate Grignard in this case. We could take this Grignard here. Okay, reacting with, say, step 1. So let me draw it so that you'll be close to what we have here. Use a blue pen. So we have our aldehyde. One, 2, 3, 4, 5. Step 1, then you say step 2, hydronium ion. So that gives us the, in other words, when we react this Grignard with this aldehyde, and then we followed it up with the hydronium ion, we get our desired secondary alcohol. Okay, so let me take all of this out so it doesn't look so cluttered. Okay, take this out, take this out. So we get our desired secondary alcohol. Now the next question is, keeping in mind that we need to start the process with this here. So the next question is, how do we get our Grignard, this Grignard here, how do we get the Grignard from this starting alcohol? Anybody has an idea? How do we get the Grignard? Exactly. Very good. So now you take this. Very good. So you convert the primary alcohol to a primary alkyl bromide. Which will now give you this here. And then you take the primary alkyl bromide to form your Grignard. Use magnesium metal in ether as solvent, and that gives you your Grignard. So what we have here, we now have our synthetic scheme by doing retrosynthesis. In other words, going backward. Let's take all of this out. Okay. Take this out. Out. This out. This out. Okay, so what do we have here? We start with this here. This is what they gave us. We reacted with phosphorus tribromide to give the primary alkyl bromide, and then we react the primary alkyl bromide with magnesium to get our Grignard reagent, and then we react the Grignard reagent with an aldehyde, the appropriate aldehyde, which is this here, followed by dilute acid, and we end up with this secondary alcohol, and finally we reacted the secondary alcohol with thionyl chloride, and that gave the final product, which is this right here. Now folks, you notice here, you could not do this problem if you have no knowledge of the reagents. In other words, you need to know what the reagents will do. Without knowing what the reagents will do, you will not be able to do a synthetic problem. This is what we call synthetic scheme. This we refer to as a synthetic scheme. Notice in synthetic scheme, you do not need to give the reaction mechanism. And so I believe we've come to the end of today's session. Let me see, just in case maybe that problem you are having with question number 6, if we know the problem is still there, so let us leave that alone. Anyway, so we have come to the end of today's session. And if you have any question, yes, somebody has a question. Is the test on December 1st or December 3rd? I don't know. You need to ask Dr. You need to ask Dr. BAKARE. What I will do, what I want to do for you guys, I want to give you guys another review session on Tuesday, next Tuesday, just before Thanksgiving. Okay? Just before Thanksgiving. Okay, so I will see you on next Tuesday. I will also send you the link and also send you a reminder. So if you have no additional questions, we have come to the end of the session today. I want to thank you for your time, and I'm sorry for the small technical problem we had during the course of the session today. Okay, unless you have any additional question, I will stay around for another 5 minutes off the record. So I'm going to turn off the recording now, so the session is officially over. But I will stay around for another 5 minutes for those who have questions to ask me off the recording. Okay, so enjoy the rest of your evening, and I will see you again next week. I will be here tomorrow also, just in case you want to take a look at today's video. Okay, so I will see you, and so long.